Hello. So today we're going to be talking about circular motion. What is that? It's in the name. It's how we define the motion of an object when it moves in a circular path. Quite easy. So let's imagine an object moving in a circular path. We can call it a planet or any sort of thing that's moving in a circle, right? The first thing we need to know is that its force, there's a force on this object towards the center of its path. And we're going to call this the centripetal force. But it's important to note that this isn't actually a type of force, but it's the name that we give to the net force causing circular motion. So this force is going towards the center of the circular path. And that's basically what's causing this object to move in this motion. So now that we know this basic, we can talk about how we're going to start describing this motion with velocity. There's two types of velocities we're going to want to consider. Number one is linear velocity. And number two is angular velocity. The first thing we're going to talk about is linear velocity. And this is what objects that undergo uniform circular motion have with a constant speed. So here's our object going in a circle, and let's say it's going this path around the circle. This is how it's moving. Its linear velocity is always going to be a tangent to that circular path. Oh, wow, oof, something like that. And it's going to be perpendicular to the force. So this right over here is our linear velocity. And no matter where it is on that circle, it's going to have that same characteristic. Tangent to the circle and perpendicular to the force. This is how we're going to describe our linear velocity. But what's important to note is that the object never actually has any displacement in the direction of that linear force. It's just one of the ways that we can describe the motion of this object. The next thing we have is angular velocity, and we denote this with this symbol. Kind of looks like a W. And so we define this as the rate of change of angular displacement. So we can write it like this. Change in theta or angle over change in time. And our units over here, units are always important in physics, is radians per second. So for an object rotating about an axis or our center, the angular velocity is going to be the same at every point along the radius. And so this is going to give us this equation over here. So now we can move on to centripetal acceleration because we know what our velocity is. Here we go. So the direction of the object is moving is constantly changing, and the velocity is changing. So we can also say that the acceleration is changing. And it might feel slightly weird to be describing our velocity as changing because actually it's moving at the same speed. But what we need to remember is that the direction is constantly changing, which is why our velocity is changing, even though our speed is constant. And that's why we have our difference between our linear velocity and our angular velocity. So with our centripetal acceleration, how are we going to write this? The easiest equation for this is, or how we're going to define it, is going to be like this. And so, we're going to recognize what these are. We have V is our velocity, R is our radius, R is also our radius over here, and T is our time period. And so just to remind everyone what the time period is, it's the time it takes for the object to complete one full revolution around their path, or basically if they can move one whole circle, the time it takes for that is their time period, quite similar to when we talk about waves. And because we know that our force, as we said over here, is always towards the center of the circular path, our direction of acceleration is also always going to be towards the center of the circular path. Now we can talk about our force here. We've already defined that it's at the center, but we can also define it using equations because we know what our acceleration is. So we have force is equal to mass times acceleration. But we can also put that in this equation over here, and we can get mass times velocity squared over radius, which gives us mv squared over r. Because we know that v squared, or v, is equal to omega r, we can substitute that into this equation. We'll have this, our r's will cancel out, and what we also get is force is equal to mass omega squared radius. So now we have two equations to work with over here. This is our other equation, and both of these we can use to define our centripetal force. You always want to remember direction, or the difference between scalar quantities and vector quantities when we're talking about circular motion, because it can get a little bit confusing. So these are going to be the basic things you need to know when talking about circular motion. And with these, with the velocity, centripetal acceleration, and the centripetal force, we can describe the motion of objects that move in a circular path, be it planets or a wheel that's rotating or whatever. Hope this helps.